What's up, everybody? Mr. Babbitt back with another video here. We got 15.2 probability. So you probably dealt with probability a little bit in math too, but the difficulty is going to increase just a little bit today. So a little recall. It says use the frequency table on the right to determine the percent of the people under the age of 20. So what we need to know first is our percent. What you're going to do there is you just take the decimal. Whoops. Let's try that again. Decimal and multiply it by 100. By doing that, you'll get the percentage. So if we look over at this table first, we want to check out the total number of people involved, and that's going to be 9 plus 6 is 15 plus 10 is 25 total people. Under the age of 20 would be this section right here and this section right here, because this is ages 0 to 9 and this is 10 to 19. So this would be a total of 10 out of 25 people. Okay, 7 plus 3 is 10 out of the 25 total. When you type this in the calculator, you get 0.40, which is equal to 40%. 40% of people. All right. Sweet. Let's get down into a little bit more about what probability is. So probability ranges from 0 to 1. 0% chance is impossible. 100% chance is certain. So 1 being in decimal form rather than percentage. So the way that you get probabilities, you put the number of outcomes that you want on top. So let's say like the probability in this example, what we wanted to know was how many people were in these age groups right there. We're going to put that number on top, which is why we put the 10 here, divided by the total. So we want to think of it as what we want divided by the total. All right, so if we look at this first example, a jar contains 32 red marbles and 28 red. What is the probability that a randomly selected marble is red? So we would say the probability of getting a red marble is equal to what we want, which is a red marble, divided by the total number of marbles. Well, our total number is 32 plus 28, which is 60. We can reduce this down by dividing both the top and bottom by 4, or just typing it in our calculator. You'll get 8 over 15. And since we want it in percent, we typed that in our calculator, and you're going to get 0.53, which will give us 53% there. All right. Let's take a look at the next one. Determine the following probabilities as a ratio and a decimal. So now we're going to leave it as ratio means a fraction, and decimal obviously means a decimal. So it says, what is the probability that a randomly selected month begins with the letter A? Well, I can tell you that the months that begin with A are April and August. So that is 2. So the probability of A is there are 2 months that start with A out of 12, because there's 12 months in the year. So we divide both of these by 2, and you're going to get 1/6. And if we do 1 divided by 6 in our calculator, that gives us approximately 0.17. All right, so that would be our ratio is 1 over 6, and then our decimal would be 0.17. All right, what is the probability of drawing a heart or spade from a standard deck of cards? So we'd say the probability of heart or spade in a standard deck of hearts. So what we can do here is we can do the probability of a heart plus the probability of a spade, and that's going to give us what we need. So the probability of a heart, well, there's 13 hearts in a deck of cards out of 52 total cards. And then the same can be said for spades, 13 spades out of 52 total cards. So when you add this together, we'll get 26 out of 52. If you type that in your calculator, you're going to get 1/2, which is equal to 0.50 there. All right. So if you don't know the stuff about decks of cards, that shouldn't be too much of a problem. I think this was just more of an introduction to what we got going on. All right. Complement of an event is just the probability of something not happening. So for example, if we look at this one right here, it says, what is the probability of that a month does not begin with the letter A? Well, we would do 1 minus this 1/6, and it would tell us that there's a 5/6 probability that it won't begin with the letter A. Okay, so we aren't going to do this. Let's take a look at this one. Conditional probability. This is the probability of an event given that something else has already happened. Okay, so we have this little formula right here that we can use. This means the probability of A and B happening given that probability of B has already happened. All right. So let's take a look here. It says a card is given from a standard deck of cards. What is the probability that a queen is drawn given that the card is red? So we'd say the probability of queen given that it's red. All right. So the way that this looks using this formula up here, we would have the probability that it's a queen and red divided by the probability that it's red. Well, if we think about a deck of cards, in a deck of cards there's 4 queens, but only 2 of the queens are red. And then in a standard deck of cards, half the cards are red. So that'd be 26 total cards there. And when you divide that, that's going to give you 1/13. So we just need to remember this formula right up here. This will help us when we're doing the probability given that an event has already occurred. All right, sweet. Independent events. So in independent, the word independent means kind of like on your own, right? So what this means is that this does not affect the outcome of another event, okay? So just because I chose a red marble once, if I put it back in, that means it doesn't give me a better opportunity to select it again. It's just completely independent of each other. So we have this other formula up here we'll talk about in just a second. It says a box containing 8 red, 7 purple, 6 yellow, and 9 green crayons. What is the probability of selecting a purple crayon, replacing it, and then selecting another? Replacing it just means putting it back in to the box. We're not taking it out and leaving it out. So the way we would write this is we would say the probability of selecting a purple, and then after that, selecting another purple. All right. And so the way that we would write this is we'd say this is the probability of selecting purple once multiplied by the probability of selecting it again. So when you have this and, you're going to multiply your 2 probabilities. So the probability of doing it once, well, there's 7 purple crayons, and if you add up all these other crayons, 8 plus 7 plus 9 plus 6 is going to give you 30. So there's a 7 out of 30 chance. And then if you put the crayon back in, well, then your chances are the same the next time, 7 times 30. All right, and so this is just going to give you 49/300. So if you're doing 2 probabilities, the probability of this and that happening, so like selecting a purple and then selecting another one, you're going to multiply the 2 probabilities. All right. Dependent events are if something does affect the outcome of the other. So let's say that, well, it's right here. So it says a box contains 8 red, 7 purple, 6 yellow, and 9 green. What is the probability of selecting 2 purple crayons without replacement? So this means that we have 30 crayons in there. We're going to select a purple one, but we're not going to put it back in. All right, so we would say the probability of purple and then selecting another purple. Well, the first time we said it's 7 out of 30. And then the second time, though, now there's only 6 purple crayons in there because the one that we already drew out, we left out. And then there's only a total of 29 crayons left because we took one of them out and left it out. So when we multiply this, you're going to get 42/870. And if we reduce this down a little more, we'll get 7/145 would be the probability of that happening. All right, let's take a look at this next page, see if we can get through some of this. We'll come back up to example 3. So let's talk about example 4. It says the frequency table shows the result of a poll of 50 randomly selected students who were asked whether they prefer to watch hockey or football. Find each probability. So first thing we want to do is we want to find our totals down here. So like the total number of boys in this would be 28. The total number of girls would be 22. The total number of people that prefer football is 24. And then the total number that prefer hockey is 26. And then you can see that these 4 numbers right here are going to add up to 50 total people. So this is the total number of people right there. All right, total people. So it says, what is the probability a student prefers football? Well, this would be probability of football, we'll say. And what we are going to do here is we would just do the number of students that prefer football, which is 24, divided by the total number of students in the entire survey, which is 50. And we can divide both of those by 2, and we'll get 12 over 25. And we'll just leave that as a fraction. If you wrote it as a decimal, that would give you, what about 0.48 or 48%? Either one there, but it'll be clear what it wants you to do. All right, what is the probability that probability a student is a boy given that they prefer soccer or prefer football? I'm sorry. So it'd be probability of someone being a boy given, this little slash means given, that they prefer football. So the formula that we use for this would be the probability of a boy and football divided by the probability of them preferring football. So a boy and football is going to be this one right here, prefers football and is a boy. So that's going to be 18 out of, and then the total number that prefer football again is 24. So 18 out of 24, which reduces down to 3/4. All right, so we'll get more and more comfortable to this idea of given and working with that. All right, the frequency table shows the results of a poll of randomly selected juniors and seniors who were asked if they attended prom. Find each probability. So again, we're going to find all of our totals here. So let's look. Total number of juniors would be 84. Total seniors, is going to be 116. People that went to prom, 125. People that didn't, 75, which gives us 200 total students in the survey. So, what is the probability a junior did not attend prom? So we'd say the probability that the person was a junior and, given that they didn't go to prom, no prom. And so the way that we're going to set this up is you would say the probability of a junior and no prom over the probability of no prom. So probability of junior and no prom. Well, how many juniors didn't go to prom? We have that. Junior is this section, and no prom is 56. So we'd say this is 56 over all the students that said no, which was 84. So 56 over 84. And when we divide this, you're going to get 2/3. 2/3. So that one's a little bit tough because it didn't say the word given, but it was kind of implied. So it says, what is the probability a student did not attend prom given that they are a senior? So probability of no prom given that they were a senior would be the probability did go to prom. They did go to prom and they're a senior. So it'd be the probability of yes and that they're a senior over the probability that they're a senior. So yes and senior is going to be right here, 97 out of all seniors, which would be 116, like that. All right. Sweet. Let's take a look at this one down here, and then we'll call it a day. It says, at a school, 11th graders and 12th graders were asked how they get to school. The results are shown in the tables. So let's write down our totals here. The total number of people that drive is 40. Total number of people that walk is 45. Total number of people that bus is 15. So there's 50 11th graders, 50 12th graders, which gives us 100 students total in the survey. All right. So it says the probability that a student who walks is an 11th grader. So it's saying we know that they walk. So this is going to be our given. Okay, we know that they walk. So we would say the probability, we're looking for the probability that they're in 11th grade given that they walk. And so the way that you do this is the probability of 11th and walk over the probability that they walk. So you're always going to do the and on top, and then on the bottom you do just the probability of the thing that's given. So 11th and walk is going to be right here. So that's 25. Out of the probability that they walk, well, how many students walk? That's going to be 45. So 25 out of 45. You divide both of those by 5, and you'll get 5/9. Like that. All right. So those can definitely be kind of tough, but just kind of remember these formulas when you have the given. We have it right down here. You're going to do probability of both of them, A and B, over the probability of what's given. All right, and we'll talk about this more when I get back.